This is the final AAA building result, optimized and ready for production. Do you want to build a building like this? Then stay with us. Hello, everyone. Continuing from the previous tutorial, in this lesson, we'll focus on creating destroyed buildings and walls. Let's take a look at the asset we used in part 1. As you can see, several damaged wall pieces are placed next to each other. For various reasons, these meshes are split into multiple parts, and this is not how we want to build them. We can either create the walls as separate modular pieces, like in the previous lesson, or build them as single meshes like these walls and use them that way. The key point is to respect the correct dimensions. For example, the height of each floor in this building is 3.2 meters, which is a standard measurement. Based on our main reference, we want the height of the first wall to be 5 floors. Other important dimensions to consider are the windows and their distance from the ground. We apply an array to the boxes and use them in a Boolean operation. According to our reference, we slightly increase the window height. However, we also need to remember that we have an entrance here, so we remove 2 of the boxes. First technique. If manually connecting all the vertices is difficult for you, you can use the Remesh technique to get fast results. However, Blender's native Remesh needs very high depth values to preserve the original shape, which makes the mesh heavy and requires extra cleanup. So it's better to use an add-on called Quad Remesher. With this add-on, you simply select the mesh and click Remesh it, and you'll quickly get a clean topology. For higher accuracy, you can also increase count and adaptive values. At this point, we have a mesh with about 8,000 polygons. But this is not the final result. We still have some extra edge loops that we don't need. We can select them using Alt for edge loops and remove them with Ctrl+X. Another method is to select all and remove unnecessary loops using loop selection. faster approach is to simply select these kinds of edge patterns wherever they appear and remove them. Now, instead of 8,000 faces, we have around 1,000 faces. This wall, with its existing edge flow, is now even ready for vertex painting. Supporting the channel. Friends, the join option has been added to our channel. By becoming a member, you support us in continuing this journey. And you'll also gain access to some project files and additional assets related to the tutorials. Thank you for your support. You can also support the channel using the Super Thanks button. Destroyed walls. Method 1. In my opinion, this method is more artistic than the others. Just like in the previous lesson, the first approach is to bevel the mesh and triangulate it. Then import it into ZBrush and remesh it there. We can also use lasso selection while holding Ctrl plus Shift, then Alt to remove certain parts. After that, we use Modify Topology Delete Hidden to completely remove those sections. And then use Dynamesh to close the holes. Now we can sculpt those areas. As you can see, in some spots we run into issues, and fixing them can be quite time-consuming. So it's better to first remove those areas using Boolean operations in Blender. Before sending the mesh to ZBrush. This way, we can sculpt much more comfortably. Method 2. In this method, we use the one-click damage plugin. This is a fast but less precise method, and it works better for smaller objects. As you can see, it applies damage to the mesh using noise and geometry nodes. It's better to apply a bevel to the mesh before using this plugin. You can assign different types of noise and adjust the values to control the damage. The second option in this plugin is Hero Mode. To access its advanced settings, you need to open the geometry settings. From there, you can control noise strength, scale, masks, and reach the desired level of detail. As I mentioned, this method works better on smaller meshes. Alright friends, I sculpted one wall in ZBrush. You can download this example for free. The link is in the description. If you'd like, by joining the channel, you can also watch the full sculpting process and gain access to the asset created specifically for this tutorial. Alright friends, I created and sculpted 5 types of walls, all with the same height. I baked them down from 18 million faces to about 10,000 polygons. I should also mention that these walls are mainly meant to fill empty spaces in the scene. In my opinion, using modular walls overall is a better approach. I created a smart material from our existing stone material and exported it, so the materials on these walls match the rest of the scene. I also exported 2 material versions, a base version and a damaged version, so we can create variation through painting. The download link for 4 additional walls, along with some extra assets, is available in the channel membership section. By joining the channel, you can access them. Now I import the meshes and, as an example, create a simple building. To enable painting, we create a material and convert it to material attributes. We add make material attributes and assign the base material and the damaged material to it. For easier control, we turn each one into a material function and blend them together using a blend material. Then, using vertex color, specifically the red channel, we can paint the blend between them. We assign the material to one of the walls. But as you can see, the second mesh already has the material applied, so we need to swap their assignments. We need to paint the vertex colors in modeling mode. We set the paint color to black and select the red channel to start painting. To improve the overall feel, we sculpt the ground around the building, so it blends better with the structure. Use as much of the detail you have as possible. As you can see, we now have a building that closely matches the reference. Next, we'll move on to the second building and start building a modular system, so we can reuse this type of building in other areas with more variation. Alright friends, in our reference we have 2 types of walls. We set one at 3 meters and the other at 2 meters, following modular principles and to allow more variation for other buildings. I also created a 6-meter wall. For the ground floor, I set the wall height to 4 meters. However, this building has an entrance that is unique on this street, so I built it as a complete piece. That said, I still try to create it using separate meshes, so some of those parts can be reused elsewhere. For what I observed in Google Maps, most buildings can be built modularly, except for 1 or 2 that have very specific entrances. Believe this. Without good references, and high-quality assets. The result will never feel realistic. Another important point to consider is the presence of basements and building elevation. Almost all buildings have a step or platform at the entrance. But since we're not creating modern buildings and need a destroyed environment, we either use cornices or damaged steps instead. Adding cornices above the windows can also help. Even though the environment is destroyed, we can still build these elements and sculpt damage into them. All right, friends, as you can see, I try to build this wall as close to the original as possible and made both the walls and the details modular, so we can reuse them in other buildings as well. Next, for creating the damaged version, I spent several hours sculpting the meshes to build both the high poly and low poly versions. Another important point to consider is having clean and well-organized UVs. In this series, we want to mix our baked textures with other textures inside Unreal Engine, so the patterns must be aligned correctly. After baking in Substance Painter, we need AO, curvature, and normal maps. We then import everything into Unreal Engine. We create a material and plug in our normal map. However, as I mentioned, we want to be able to mix other textures with this material. So we add a blend angle corrected normals node and use a texture sample parameter 2D for the second normal input. Finally, we connect the result to the normal output. At this point, you should create a material instance and assign it to the model. Now, in the second normal parameter, you can add any normal map you want. Keep in mind that if only our own normal is used, you'll see just the original baked details. If we want to control the strength, we add a flattened normal node with a scalar parameter. The lower the value, the stronger the normal appears. You can't connect ambient occlusion directly on its own, but if you add a 1- node, take the red output and multiply it, you can increase its intensity and control it properly. Now, let's move on to the curvature. First, select it and add another texture sample parameter. We take the red output, connect it to a power node, and then connect that to a multiply node. Next, we create a parameter and name it edge intensity. And for example, set its value to 0.5. Then we combine it with 1- AO. Now we have a mask. Next, we add another texture parameter. We want to use the mask we created to make the edges brighter. So, while holding Alt, we create a lerp node. And by using a multiply with a value of 1.5, we achieve this effect. We connect our mask to the alpha input. Let's see what happens. Now we can assign any base color to the mesh material. At the same time, we get brighter edges, and we can clearly see the difference using Fresnel power. By adjusting edge intensity, we can control how strong the effect is on the edges. Thanks a lot for watching the video till the end. If you enjoyed it, don't forget to like, leave a comment, and share your thoughts. Your support really helps the channel grow. And you can also support us using Super Thanks. Thanks again for being here, and see you in the next episode.